This episode is brought to you by Squarespace. Squarespace, build it beautiful.
Imagine a spacecraft with a huge, shiny sail attached like a kite accelerating through space. But there's no wind in space. This sailship is pushed by sunlight. Think about it. Photons or particles of light have no mass, and yet they can push you. The push of a single photon of visible light is tiny, less than 100 quintillionth of the force of a snowflake falling on your cheek. But let's put it this way, if every single photon landing on your face had the same momentum as a snowflake, it would feel like all of the snow from Mount Everest were falling on your face every second. Standing in the sun wouldn't be so easy. And there's no friction in space to slow down the sailship, so it would just keep building up speed over time. So how do we take this light push and turn it into a light sail? Well, when the photon reflects off of the light sail, it's a simple transfer of momentum. Think of billiard balls. When the billiard ball gets hit by a cue ball, it gets a kick, just like the light sail gets a kick from a reflecting photon. In addition, if the balls bounce off of each other, the billiard ball moves much faster than if, say, you put Velcro on both balls and they stuck together. Similarly, a light sail works much better if it's reflective and the photons bounce off instead of being absorbed. And forward you go, with just the push of light. Japan's Ikaros light sail uses this phenomenon to even steer their craft. What they do is they can change the reflectivity on the sides of the solar sail in real time using liquid crystals, similar to the crystals in your LCD screen. By changing the reflectivity around one edge of the solar sail, they can make it so that the shinier side is pushed more than the other side and thus pivot and steer the craft. You don't have to move anything, and you can steer using liquid crystals. That's ingenious! And fun fact, Icarus is a character from Greek mythology that flew too close to the sun and the wax on his wings melted off. Oops. Now, I think the coolest thing about solar sails is that light can push things at all. It seems pretty straightforward. The photons come in and pelt the light sail, pushing it forward, just like air molecules in wind pelt a boat's cloth sail and push it forward, right? Well, no, because molecules have mass, unlike photons, which have no mass. They are precisely 0 kilograms. And you learn in physics class that momentum equals mass times velocity, so no mass means no momentum. But then quantum mechanics class comes along and tells you, well, actually there's another way that you can get momentum, and it's if something has energy. And light does have energy, so it can have momentum. Just another thing that quantum mechanics came in and turned upside down. And let me just say, solar sails aren't science fiction. They are the now. In 2008, NASA launched a small solar sail satellite to orbit Earth called the NanoSail D. D for Diana. Just kidding. Also in that year, Japan launched its interplanetary explorer, Ikaros, which made it all the way to Venus in less than 7 months. This upcoming year, the Planetary Society plans to launch LightSail, a crowd-funded satellite the size of a loaf of bread, which seems pretty small, but a smartphone now has more processing power than the computer on the lunar missions had. A rocket will carry LightSail into space, where it will be ejected into orbit. Then, LightSail's estimated acceleration under constant direct sunlight is 0.06 millimeters per second squared, or an increase of about half a mile per hour every hour. And the bigger you make your light sail, the larger that acceleration. In addition to light sails, we've harnessed this property of light where it can exert a pressure and thus a force here on Earth too. Scientists have developed optical tweezers using lasers to trap and study single biological cells, to stretch single DNA molecules, and to trap single atoms. So they're more of a trap than tweezers, but I digress. So why light sails? What do they add to space exploration? Well, they're low cost, not too heavy, and they last a really long time. Spaceflight is really expensive and complicated, so light sails are just another one of those technologies inspired by physics that aims to decrease costs and make spaceflight easier. Plus, they're super cool. It's a satellite being pushed by light. What more could you ask for? Thank you so much for watching this episode of Physics Girl, and happy physicsing. This episode is brought to you by Squarespace. Squarespace helps to build websites, blogs, and online stores for you and your ideas. Websites look professionally designed regardless of skill level. No coding required. Try Squarespace at squarespace.com/physicsgirl for a special offer. Squarespace, build it beautiful. One more thing. Solar sails sound like solar cells, which are the photovoltaic components in solar panels, but the two are distinct technologies and actually work because of different physics. Solar sails are literally pushed by the photons, while solar cells use the photoelectric effect and absorb the photons and convert that energy into electricity. Solar sails are actually more efficient. They can convert about 90% of that energy into motion of the solar sail, while current photovoltaics can only convert about 40% of the absorbed energy into electricity. But the photovoltaics actually absorb the energy of the photons, so they can still produce and store more energy. Now you know.